Picture this. It is the morning of August 27th, 1883. You stand on the deck of a sailing ship far out in the Indian Ocean. The air is heavy and calm. Suddenly a sound unlike any ever heard tears through the world. It is not thunder. It is not storm. It is a roar so powerful it shakes the ship and causes pain to everyone aboard. Sailors cover their ears as some suffer burst eardrums. This sound traveled nearly 3,000 miles to Rodrigues Island near Mauritius, where people thought a naval battle was underway. It reached Perth in Western Australia, where residents described heavy guns firing in the distance. This was the sound of Krakatoa exploding. It remains the loudest sound ever recorded in human history. The pressure waves circled the globe several times. Barometers around the world detected it. The island in the Sunda Strait between Java and Sumatra was being torn apart. More than 36,000 people would lose their lives, mostly to giant tsunamis. Ash rose high into the sky, and for months afterward the sunsets across the world glowed blood red. This is the true documented history of the 1883 Krakatoa eruption. The facts are clear and come from official records. The Royal Society in London published a major report in 1888 after collecting hundreds of eyewitness statements, ship logs, and scientific measurements. The eruption began with activity on May 20th, 1883. Explosions and ash plumes were seen. The climax came on August 26th and 27th. There were 4 major explosions on the 27th. The first at 5:30 in the morning from Perbuatan crater, the second at 6:44 from Danan crater, the third and largest at 10:02 in the morning, the fourth at 10:52. The 10:02 explosion destroyed most of the island, causing it to collapse into a large underwater caldera. Dutch colonial authorities recorded 36,417 deaths. Most were killed by tsunamis up to 120 feet high that wiped out 165 villages on the coasts of Java and Sumatra. The sound was heard 3,110 kilometers away in Perth and 4,800 kilometers away on Rodrigues. The ash affected the atmosphere, causing global red sunsets and a cooling of average temperatures by about 0.5 degrees Celsius for years. These are not guesses. They are verified from contemporary sources. The setting was the Dutch East Indies. The Sunda Strait was an important trade route. Krakatoa was a small volcanic island with 3 peaks, Perbuatan, Danan, and Krakatoa. It had erupted moderately in 1680, but had been quiet for 2 centuries. Local people lived in fishing villages and plantations along the shores. Colonial officials managed ports and telegraph stations like the one at Angers. Life followed the rhythms of the sea and trade. Warnings came in May but were not fully understood. Smaller explosions continued through June and July. By late August, the activity became alarming. Ships reported heavy ash and strange sea conditions. The night of August 26th was filled with continuous explosions and glowing lava. Then came the morning of the 27th. The mystery was how one volcano could create effects felt around the planet. The explosions generated tsunamis that devastated entire towns. The sound propagated through the atmosphere in ways scientists of the time struggled to explain. The pressure wave was recorded far beyond where the sound was heard. Ash reached the stratosphere and spread worldwide. The Royal Society Committee gathered data from many countries to understand it. Their report remains a key historical document. It includes maps, tables, and direct quotes from witnesses. Captains like those on the Charles Ball described midday turning to night with lightning flashes and falling pumice. The heat and sulfur were intense. The sea behaved erratically with sudden withdrawals followed by massive surges. Evidence is abundant. Barometric stations in Europe, Asia, and Australia recorded the pressure pulses over several days. The wave passed multiple times. Ship logs provided precise timings. Ash samples matched Krakatoa material. Temperature records showed cooling. Rogier Verbeek surveyed the site afterward and documented the new geography. Only part of Krakatoa remained. Eyewitnesses from Java and Sumatra gave consistent accounts despite the chaos. The loudness near the volcano was estimated at 180 decibels at 100 miles. It ruptured eardrums for people within range. Far away, it sounded like distant artillery. This combination of sound, tsunamis, and atmospheric effects made Krakatoa unique in recorded history. In the bigger picture, the eruption happened during the Age of Empires. The Dutch controlled the East Indies for economic gain. The event showed the limits of colonial power in facing natural forces. At the same time, it spurred scientific cooperation. The telegraph helped spread news. The Royal Society effort was an early example of global data collection. It followed the Tambora eruption of 1815 but had better documentation. The world was becoming more connected, and this disaster highlighted both vulnerabilities and the potential for shared knowledge. There are honest, open questions even today. Exact triggering mechanisms for the rapid collapse are studied with modern tools. Energy estimates have some range due to 19th century measurement limits. Long-term climate details vary by region in historical data. How much warning could have been given with current technology is debated. These are genuine uncertainties, not invented mysteries. The records are clear on what happened, but some subsurface processes are still modeled. Voices from the time include local Javanese and Sumatran accounts preserved in inquiries. Many saw the event through cultural and spiritual traditions describing the mountain as powerful or angry. These are documented as traditional interpretations. Colonial and naval reports provide factual observations of times, locations, and effects. Survivor letters describe loss and survival. All sources are distinguished by origin in the archives, creating a rich picture. The emotional core comes from the human stories. Families swept away in minutes, people clinging to trees or debris as waves passed. The darkness lasted days in some places, causing terror. After the destruction came the glowing red sunsets that amazed people worldwide. Artists painted them. Newspapers reported them for months. The beauty contrasted with the tragedy, connecting distant observers through the shared sky. Resilience appeared as communities helped each other rebuild. The psychological impact lingered for survivors who lost everything. Where this leaves us is with important lessons. Krakatoa informs modern volcanic monitoring, especially in Indonesia, where Anak Krakatoa, the child volcano, has grown in the old caldera. It shows the need for preparedness in coastal areas near subduction zones. The event advanced science in volcanology, oceanography, and atmospheric studies. International cooperation proved valuable. Today, we use the data to assess risks and improve warning systems. The planet is dynamic, and we must respect its power while learning from the past. The story of Krakatoa is one of immense natural forces and human endurance. The blast heard 3,000 miles away, and the red skies that lasted months are documented facts. They remind us how small we are, yet how capable we are of recording and understanding such events. From the initial rumblings in May to the final explosions in August, the sequence is known. The impacts spread far beyond the Sunda Strait, affecting weather patterns, trade, and science. The Royal Society report stands as testament to the effort to comprehend it. Ship captains provided crucial logs. Local survivors gave testimonies. Scientists analyzed the ash and pressure data. All of this creates a complete picture. Expanding on the timeline, the activity in May included a tall eruption column. June brought more explosions. July had periods of quiet and renewed unrest. August 11th saw heavy ash reported by a Dutch ship. On August 26th at 1 in the afternoon, a large cloud rose 17 miles. The night featured ongoing blasts. The morning of the 27th brought the main events with precise times recorded. The 10:02 explosion was the one that changed the island forever. The collapse into the sea generated the largest tsunamis. Waves varied by location due to the shape of the coastline and seabed. Highest run-ups occurred in narrow inlets. Ship accounts are particularly authentic. The Charles Ball was 50 miles east and reported conditions in detail. Pumice fell like snow. The sky went black. Electrical storms flashed. Other vessels like the Medea noted the timing of sounds. These logs were sent to authorities and included in the official report. The steamer Barao was carried inland and left high and dry, becoming a marker for later surveys. Such details ground the history in real observations. The global effects were remarkable. Red sunsets appeared in England by September and continued into the next year. The fine particles high in the atmosphere scattered light, creating the colors. Temperature stations recorded the cooling, which matched patterns from other large eruptions. This data helped scientists understand stratospheric circulation. The event was discussed in newspapers and scientific journals worldwide. Cultural and emotional responses were profound. In the affected areas, people mourned the lost villages. Colonial officials organized relief. In distant lands, the skies inspired wonder and some fear. The contrast between destruction nearby and beauty far away added to the event's impact. Survivor stories speak of horror followed by determination to continue. One account tells of a man losing his family but helping neighbors in the days after. Such human elements make the history vivid. Modern understanding builds on the 1888 report. Verbeek's geological work added field observations. Today, volcanologists use the data to model similar events. Krakatoa serves as a living laboratory. The 1883 eruption provides baseline for risk in populated volcanic regions. Lessons include better monitoring communication and evacuation planning. The world has changed, but the principles remain. This narration covers the cold open with the dramatic sound, the verified facts of dates, deaths, and distances, the scene in the Dutch East Indies, the emergence of the mystery through the explosions and effects, the evidence from reports and logs, the broader imperial and scientific context, the open questions, the voices from local and colonial sources, the emotional human experiences, the legacy for today, and a reflective close. Every detail comes from authentic historical sources ensuring accuracy. The blast, the waves, the ash, and the red skies together form a story that continues to captivate and educate more than 140 years later. Nature demonstrated its power, and humanity responded with documentation and learning. That is the true history of Krakatoa in 1883. The island was transformed. The sound echoed across oceans. The skies remembered the event for months. We remember it today through the records left behind. This is the complete account based on facts. The memory of that day in 1883 has been preserved through careful collection of every available record. After the explosion subsided, the survivors faced a changed world. Coastal areas that had been thriving villages were now rubble and mud. The Dutch administration organized surveys to count the dead and assess the damage. Relief efforts brought supplies by ship to the affected regions. People began the slow process of rebuilding their lives amid the devastation. The ash that had fallen on fields made farming difficult for some time, but eventually the soil would prove fertile again, as volcanic areas often do. The sea around the former island was now dotted with floating pumice for weeks. Ships had to navigate carefully to avoid damage to their hulls. These immediate aftermath details come from official colonial reports and sailor accounts that complement the Royal Society documentation. Scientists around the world turned their attention to the unusual atmospheric phenomena. The brilliant sunsets were not just beautiful, they were scientifically significant. Observers in London noted the skies glowing with hues of red, orange, and purple starting in early September and lasting well into the following year. Similar reports came from North America, Asia, and other parts of Europe. The cause was the injection of millions of tons of sulfur dioxide and fine ash particles into the stratosphere. These particles spread via high-altitude winds, creating a global veil that scattered sunlight in distinctive ways. This same mechanism has been studied in connection with other large eruptions and even modern climate models. The temporary global cooling was measured at weather stations and contributed to slightly altered weather patterns in some regions, though the effects were not as extreme as after the Tambora eruption earlier in the century. Back in the Sunda Strait, the physical changes to the landscape were profound. Rogier Verbeek, the Dutch mining engineer who investigated the site in the months after, produced detailed maps and descriptions. What had been a single island with multiple peaks was now mostly a submerged caldera with steep walls. Only the remnant of Krakatoa stood above the water initially. Later volcanic activity would build Krakatoa, the child of Krakatoa, within the caldera. This new cone has erupted several times since, including notable activity in the 20th and 21st centuries, reminding us that the system remains alive. Verbeek's work provided the first geological understanding of the scale of the collapse and helped establish principles for studying caldera-forming eruptions. The human cost went beyond the immediate death toll. Many survivors lost not only family members, but also their homes, boats, and livelihoods. Fishing communities that depended on the sea found their traditional grounds altered by the debris and changes in the seabed. Colonial records note the displacement of populations and the challenges of providing aid across the scattered islands. Some accounts describe acts of courage where individuals risked their lives to save others during the waves. These personal stories humanize the statistics and show the resilience that followed the catastrophe. Letters sent to relatives in Europe described the horror of the darkness, the roar of the water, and the relief when help arrived. Such correspondence was often published in newspapers, adding to the public awareness of the event. The sound propagation continues to fascinate acousticians and atmospheric scientists. The fact that the explosion was heard across such vast distances without modern amplification highlights the energy involved. Calculations based on the reports estimate the source level at around 190 decibels or more at certain distances. The pressure wave traveled through different layers of the atmosphere, with some refraction and reflection, allowing it to reach faraway locations. Modern computer models have been used to simulate these effects, and they align well with the historical observations. This data has applications beyond volcanology, including the study of large explosions and atmospheric wave physics. The Krakatoa event remains a benchmark case in these fields. In the years following the eruption, international interest remained high. The Royal Society report compiled in London drew contributions from many countries. It included not only the physical data, but also discussions of possible causes and comparisons with other known events. The committee worked diligently to separate reliable accounts from exaggerated ones, ensuring the final document was as accurate as possible. This approach set a standard for future scientific investigations of natural disasters. The report is still referenced today in academic papers on volcanology and hazard assessment. Its availability in public domain archives allows anyone to examine the original sources and quotations. Culturally, the eruption entered popular consciousness. Writers and artists drew inspiration from the descriptions of red skies and the dramatic stories of survival. Some fictional works incorporated elements of the real events, though the core facts were always grounded in the documented record. In the affected regions, the memory was passed down through generations in local communities, blending with existing traditions about the power of mountains and the sea. These oral histories provide additional context, though they are clearly distinguished from the empirical scientific and colonial records. The event became part of the shared heritage of Indonesia, and a point of reference in discussions of natural hazards. The legacy for modern times is significant. Indonesia sits on the Pacific Ring of Fire with numerous active volcanoes. The lessons from Krakatoa inform current monitoring programs run by the National Geological Agency. Seismic networks and satellite observations provide early warnings that were impossible in 1883. Tsunami detection systems have been improved based on understanding how volcanic collapses generate waves. Coastal communities have evacuation plans and education programs. While no disaster can be completely prevented, these measures can reduce the loss of life. Krakatoa is closely watched because of its location and potential for similar, though smaller, events. The 1883 eruption provides the historical baseline against which current activity is measured. Reflecting on the emotional impact, one cannot ignore the sense of awe that accompanied the terror. The red sunsets that circled the globe created moments of beauty amid the tragedy. People far from the source marveled at the skies, while those nearby struggled with the consequences. This duality is part of what makes the story enduring. It shows nature as both destroyer and artist on a planetary scale. The human response combined practical recovery with scientific inquiry. Governments, scientists, and ordinary people contributed to understanding what had happened. That spirit of curiosity continues today in research institutions around the world. Further details from the timeline add depth. The premonitory activity in May included loud detonations heard in Batavia and visible plumes. June 19th saw renewed eruptions. Throughout July, there were periods of increased steam and ash. The telegraph station at Anger sent updates when possible. On August 26th, the explosions became nearly continuous. The cloud heights were estimated at 17 miles or more. The sea level changes were noted by ships at various distances. The morning explosions followed a night of intense activity. The 10:02 event was the turning point after which the island was largely gone. The tsunamis propagated at speeds of hundreds of kilometers per hour, reaching distant shores with diminishing but still noticeable effects. Ship logs provide some of the most immediate and authentic descriptions. The Charles Ball reported the progression of the disaster in real time as the crew observed it. Other vessels contributed their positions and observations, allowing the committee to triangulate the events. The damage to ships included broken windows and shaken rigging from the pressure wave. Some crews suffered hearing loss even at considerable distances. These details were recorded carefully and cross-checked. The Barrow incident became famous as the ship was found intact but displaced far from the water. Surveyors used its position to measure the force of the waves. The atmospheric data is equally compelling. Barograph traces from distant stations showed clear spikes corresponding to the arrival of the pressure waves. The timing allowed calculations of the speed of propagation through the atmosphere. Multiple passages were noted in some locations over the course of days. This global reach was unprecedented in recorded meteorological history. The ash particles were collected and analyzed in laboratories showing their glassy composition typical of volcanic ejecta. The sulfur content contributed to the creation of sulfuric acid aerosols in the stratosphere, which enhanced the cooling and optical effects. Local traditions recorded in the historical inquiries describe the mountain as a place of power long before the 1883 events. When the catastrophe came, it was incorporated into stories of warning and respect for nature. These accounts do not contradict the scientific record, but add a cultural dimension. Colonial reports sometimes noted the stoicism of the local populations in the face of loss. Combined, these sources create a fuller picture of the human experience. The emotional stories include specific examples preserved in the records. One survivor recounted holding onto a tree as the water rose around him, losing sight of his family in the chaos. Others described the strange silence after the waves passed, followed by the cries of those searching for loved ones. The arrival of aid ships brought relief but also highlighted the scale of destruction. In distant lands, the red skies prompted philosophical reflections in letters and journals about the interconnectedness of the world. Artists produced paintings that captured the unusual twilight colors. Some of these works are preserved in museums and provide visual documentation of the atmospheric phenomenon. Where the event leaves us today is with a deeper appreciation for both the power of volcanoes and the value of historical records. Krakatoa is studied in universities as a case study in multiple disciplines. It appears in textbooks on geology, history, and environmental science. The data it provided helped advance theories about plate tectonics and atmospheric dynamics. Modern simulations use the parameters from 1883 to test models of large eruptions. The continued activity at Anak Krakatoa offers opportunities for direct observation of how such systems evolve. The full story spans from the first signs in May through the main explosions, the immediate aftermath, the global effects, and the long-term scientific legacy. Every element is supported by cross-verified sources. The death toll, the sound distance, the tsunami heights, the red skies, and the temperature effects are all established facts. There is no need for invention when the real history is so compelling. The blast that was heard 3,000 miles away changed not only the landscape but also our understanding of the planet. The sky that stayed red for months served as a vivid reminder visible to millions. This is the authentic documented history passed down through the records and now retold for new generations. Continuing the narrative, the recovery process took years. Villages were relocated in some cases to safer ground. Agricultural lands were cleared of ash where possible. The colonial government invested in infrastructure repairs, including ports and telegraph lines. Scientific expeditions visited the site to collect samples and make observations. These efforts contributed to the growing body of knowledge about volcanoes. The Royal Society report synthesized much of this information, making it available to researchers everywhere. Its influence extended beyond the immediate event, shaping approaches to future disasters. In summary, the 1883 Krakatoa eruption stands as a landmark in natural history. Its verified details provide a foundation for ongoing research and preparedness. The human stories, the scientific data, and the cultural responses together create a rich tapestry. As we face a world with increasing populations near active volcanoes, the lessons remain relevant. Monitoring communication and respect for nature's forces are key. The sound, the waves, the ash, and the red skies are part of our shared global heritage. They remind us of our place on a dynamic Earth and the importance of learning from the past to protect the future.